In part 1, we used properties to determine substance type and to identify ionic compounds and molecular compounds. In this part, we're going to look at acids and bases and their properties. You have a colorless solution and add 1 drop of phenolphthalein. The solution turns pink, so stop the video and fill in this blank. And the answer is a base. Okay, so stop the video and review the definition of acids and bases and properties of acids and bases. We looked at phenolphthalein earlier. If you ever said a bad word and got your mouth washed out with soap, it was supposed to leave a bitter taste in your mouth. Let's review pH, so stop the video and answer these questions. The answers are, let's see how these quantities are related. pH is a measure of the hydrogen ion concentration. These brackets mean concentration in molarity. pH is a logarithmic scale, so a pH 1 solution has 10 times the H plus concentration than a pH 2 solution. Note that the higher the pH, the lower the H plus concentration. We'll do pH calculations later in this course. Compare solution A and solution B. Stop the video and answer these 3 questions. And the answers are, B is the neutral solution because H plus equals OH minus. A is the acid solution because H plus is greater than OH minus. And neither solution is a base. Compare solution A to solution B. Stop the video and answer these 2 questions. And the answers are B, higher pH means lower H plus concentration. And for the second question, A, because higher pOH means lower OH minus concentration. Let's review. Stop the video and answer these 3 questions. And the answers are, good work. Life involves give and take, so stop the video and determine which hand is the acid. And the answer is the left hand. Acids are substances that donate protons, that is, they're givers. Bases are substances that accept protons, that is, they're takers. Let's take a look at a chemical reaction. Stop the video and answer these 2 questions. And the answers are, so here's what's happening. HA gives up or donates the proton to H2O. When HA loses proton, it becomes A minus. When H2O gains proton, it becomes H3O+. Acids are classified as either strong or weak, so stop the video and answer these 2 questions. And the answers are, a big spender is like a strong acid, easily gives up his money. A cheapskate, like a weak acid, doesn't want to give up his money. Muriatic acid is a strong acid. Stop the video and figure out which picture best describes HCl. And the answer is A. A strong acid easily donates its protons and completely dissociates into its ions in water. Acetic acid, which is the acid in vinegar, is a weak acid, so stop the video and determine which picture describes acetic acid. And the answer is C. A weak acid wants to hold on to its proton and only partially dissociates into ions. Acids are either strong or weak. Bases are strong or weak too. Let's relate acid strength to pH. So remember, low pH means high H plus concentration. High pH means low H plus concentration. Earlier we talked about how a conductivity experiment measures the number of ions in solution. Stop the video and answer these questions. And the answers are, high pH means low H plus concentration, so based on what we just discussed about pH conductivity, stop the video and answer this question. And the answer is, here's the reason. A strong acid has a high conductivity due to the many H plus ions in solution. High H plus concentration means lower pH. When an acid loses its protons, it forms H plus and its conjugate base. This anion is a base because it can gain or accept protons to reform the acid. Let's review these concepts of acids and bases. Stop the video and answer these questions. And the answers are, these are properties of bases. When HCl loses a proton, Cl minus is left over. That's the conjugate base. Remember that a strong acid easily donates its protons and completely dissociates into ions. Stop the video and answer these questions. And the answers are, a strong acid dissociates completely into its ions, which means there's a lot of ions. A strong acid has a higher concentration of H+, which means lower pH. You're given a colorless liquid. Perform the following tests and make these observations. Stop the video and identify the liquid. And the answer is because the liquid is not an acid or a base, which means it's neutral, and water is neutral and has a low conductivity. Let's practice applying acid-base properties to identify a substance. Stop the video and answer these questions. And the answers are: sulfuric acid and acetic acid have low pHs. Sugar is neutral. Sodium hydroxide is a base and has the highest pH. The litmus and pH tests tell us whether a substance is acid, base, or neutral. Using the vernier conductivity probe that we use in our lab, 1,000 microsiemens per centimeter is low conductivity. So based on these observations, the liquid is, remember, test, don't taste. In this video, you identified properties to identify an acid, base, or neutral substance.